Hello and welcome. So we're talking about absolute value and then inequalities with absolute value today. So absolute value, it's just interested in the magnitude of the difference between the two numbers. We're thinking about magnitude, so we're thinking about the distance between two numbers on the number line, or if we just have one value, then from that particular value to the origin, to the 0 point. Of course, distances can only be positive, so the absolute value will always only return positive numbers. And absolute value, again, it's the magnitude of the distance under consideration. So for instance, the absolute value of 4 minus 5, the interpretation here is this is the distance on the number line between the number 4 and the number 5. So that distance is 1 unit, therefore we say the absolute value is 1. Now, of course, you're looking at this doing the subtraction, that's going to be a -1, but since we're interested in the actual distance, we're going to convert that -1 to a +1. Okay, so more formally, on the number line, the absolute value of number x is simply the distance between 0 and x. So we denote this as the absolute value of x. See, upper vertical bars here. Now, distances can't be negative, so the absolute value is always positive. And this gives rise to an interesting function. So we define the absolute value function as f of x is equal to the absolute value of x. And here's what this thing looks like. It's composed of two pieces. One piece you'll recognize is just the line y equals x. Remember, the function y equals x just takes whatever is the x value, and that itself is the y coordinate. So for any this is pairs of x's and y's such that it's the same number. So this is like 0, 0, 1, 1, 2, 2, 4, 4, 6, 6, 8, 8, so on. This right here, then, the other component is the line y equals minus x, the negative of the line y equals x. So here we're going to take whatever is the x value, whatever is the x coordinate, we're going to take its opposite to give us the y coordinate. So if x is minus 2, then the y is going to be +2. If x is -4, the y is +4. If x is +2, then y is -2. Oh, but for the absolute value function, we ignore that portion, right? So the absolute value function is defined by the line y equals x. For positive x, it's defined by the line y equals -x for negative x, right? Okay, we'll talk more about that a little bit later, but basically this is what's necessary for the absolute value function to always return positive values. If the value itself was negative, we return its opposite. If the value itself was positive, that is our output. Okay, so evaluate and interpret the following expressions. Absolute value of 50, absolute value of -2, and absolute value of 0. So stop the video and think about the interpretation, right? You know, you can look at this and you kind of know what these all have to be positive, and that's going to be the absolute value. Well, think about the interpretation in terms of the distance, right? So here we go. Absolute value of 50 is the distance between 0 and 50. So the absolute value of 50 is 50. Absolute value of -2, well, it's the distance between 0 and -2. So it's 2 units. So absolute value of -2 is 2. Absolute value of 0, the distance between 0 and itself, it's 0. Right? And we can refer back to the graph here for some insights. You can think about how absolute value is always going to be positive. It's always taking, if the value is positive, it's returning the value itself. If the value is negative, it's returning its opposite. Okay. More generally, we can talk about the distance, absolute value of a minus b. And look, crucially, the way that we're defining this distance between a and b is a minus b, not a plus b, a minus b. Okay, so the absolute value of 10 minus 2 is 8. This tells us there's 8 units between 10 and 2 on the number line. And it doesn't matter if we write absolute value of a minus b or the absolute value of b minus a. One of these is going to, depending on whichever is bigger, if a is bigger than b, this is positive. If b is bigger, if a is bigger than b, then this is negative. The absolute value is going to return a positive either way. Why? Well, distances are positive. The distance between Ann Arbor and Detroit is the same as the distance between Detroit and Ann Arbor. Right? Okay, so let's interpret each expression, evaluate the distance between 6 and 4, the distance between 4 and 6. And what's this one? 4 plus 6. Think carefully about that. Right, stop the video and do the interpretation. So what is that? Well, absolute value of 6 minus 4 gives us the distance between 6 and 4. That's just 2, so absolute value of 2 is 2. Absolute value of 4 minus 6 gives me the distance between 4 and 6, so 4 minus 6 is -2, but we're interested in the distance, so that's +2. right? All right. And 4 plus 6 gives us the distance between 4 and negative 6. Ah, what's going on here? Well, remember, we defined the distance as a minus b. Ooh, but this is 4 plus 6, so we have to recast this to be an a minus b. And for that to work, we have to make a negative minus a negative. Minus minus is a positive, so that's how we can do this. So to get this in the form a minus b, we can write this as 4 plus 6 is 4 minus negative 6, right? And the distance between this, well, these are 10 units away on the number line. So that's why the absolute value, well, the absolute value of 10 is 10, so that's why the absolute value is 10. That's why this has this interpretation of 10 units apart. Okay, so the algebraic definition for absolute value, this comes from the absolute value function that I showed you a second ago. For values that are positive, we say the absolute value is just itself. If x is positive, if it's already positive, the absolute value of x is x. Now what if x is negative? Then the absolute value of x, of a negative x, is going to be the opposite of that negative x, which must be a positive. Because if we're using this information, we're assuming x is negative. This is like negative 2, negative 3, negative 4. We need to take the opposite of all those things to make it a positive 2, positive 3, positive 4. So let's think about this a little bit more. So for positive x values, well, whatever is that value, positive 2, the absolute value of positive 3, the absolute value of positive 3 is just 3. Positive 2, the absolute value of positive 2 is just positive 2. Or what if x is negative? Minus 2. The absolute value of minus 2 is its opposite, minus a minus 2, which is positive. If x is negative 3, the absolute value of that negative number is minus that minus 3, or positive 3. Right? So if our input to the function is a negative x, then the output has to be its opposite. The opposite of a negative is a positive. So that's all that definition's given us. Okay, let's evaluate these here. Absolute value of negative 5. How do we do this? Well, clearly this is a negative value, so we have to take its opposite. So you know absolute value of a negative number is just positive version. So you know the absolute value of negative 5 is 5. All right, let's do it mathematically following the definition. Since we have negative 5 here, we need a negative 5, and that's going to give us that's going to give us a positive 5. What about this? T over absolute value of t. If t is negative, well, t is negative, and that's going to stay negative. Absolute value of a negative number means we take the opposite of that negative number. So this becomes positive, but you know that because the absolute value of t is positive, but this is still negative. So we have a negative t divided by a positive t, which gives us negative 1. And this is that work. Remember, this is negative by definition. This is negative, but we're going to take its opposite. So t's cancel, and we'll get a negative 1. Okay. Absolute values and inequalities. So we can use the geometric interpretation of absolute value of x to solve equations involving absolute values. So for instance, let's solve for x. Absolute value of the distance between, absolute value of x minus 3 is the distance between x and 3 is equal to 7. Here we have absolute value of x plus 2 is equal to 10. Absolute value of x minus 5 is equal to minus 4. All right, stop the video, give it a try. Okay, well this first one, I mean, just staring at this, look, the quantity x minus 3 needs to either be positive 7 or negative 7, because the absolute value of both of those is going to be positive 7. How do we get to positive 7? Well, we can have 10 minus 3. How do we get to negative 7? Well, we can have minus 4 minus 3 is minus 7. And then the absolute value will be positive 7. So that's this explanation here. What about for this one? Absolute value of x plus 2? Well, x plus 2 can be positive or negative 10. The absolute value thereof will be 10. How do we get there? Well, x can be 8, or x could be negative 12. Negative 12 plus positive 2 is negative 10. Absolute value of negative 10, 10. And then lastly, absolute value can never be negative, so there's no solution. This is nonsense. X minus 5, absolute value, has to be positive. Okay, so let's go a little bit further and let's think about solving absolute value equations algebraically. So for instance, suppose we have absolute value of x minus 2 is equal to 4. Well, we know we know x minus 2 can either be positive 4 or it can be negative 4. So we know that the quantity x minus 2 is between negative 4 and positive 4. So we could actually write that out with inequalities. We could write negative 4 equals x minus 2. Well, negative 4 is less than x minus 2 is less than 4. I was saying that when I was seeing this equals here. Okay, so to actually solve this, though, we can just recognize and validate those two possibilities. So we can have x minus 2 is equal to 4, or x minus 2 is equal to negative 4. Either way, take absolute values, we're going to get equals 4. Okay, so just solving, we can find x can be 6 or x can be minus 2. Plugging in 6 minus 2 is 4. Sure, that works. Minus 2 minus 2, that's minus 4. Absolute value is positive 4, so that works. Okay, inequalities involving absolute value. Since x gives the distance between 0 and x, the inequality absolute value of x is less than 3 tells us the difference between 0 and x must be less than 3. So the value of x must be somewhere between negative 3 and positive 3. So we write the solution as x is less than 3, x is greater than negative 3. Because both conditions must be true, we can summarize that concisely, really succinctly, as minus 3 is less than x is less than 3. Right? Let's test some values. Let's try 0. Absolute value of 0 is less than 3. Yeah, it is. 0 is less than 3. Let's try some extreme values. 4. Is the absolute value of 4 less than 3? No. So things greater than, values greater than 3 are not going to be in our solution set. And then what about like negative 4? Absolute value of negative 4 is positive 4. That's not going to work. So yeah, indeed, this is going to be the only values of x that will make this statement true. Okay. Suppose we have absolute value of x is bigger than 3. This means the distance between 0 and x is greater than 3. Well, we need that x is not between negative 3 and 3. It can't be closer to 0 than 3 in absolute value. And it cannot be exactly minus 3 or 3 because this does not have an or equal to. This is just a less than. So our solution set are x is smaller than negative 3 and larger than positive 3. So we're looking at really extreme values relative to 3. There's no more compact way to write this because these signs disagree. You cannot have the two signs pointing to each other like this. That never works. Okay, so let's try some values. Let's try 0. 0 is between negative 3 and 3. Oh, absolute value of 0 is not bigger than 3. Right? So you can tell our solution set has to be the more extreme values. Okay. Solve each absolute value inequality. Okay, so we have absolute value of 3x minus 4 is less than 10, and 2 minus 3x is bigger or equal to 12. Well, here's a little interlude. Suppose we have absolute value of x of a minus b less than c. When we remove the absolute value, we can get this statement. Negative c is less than the quantity a minus b is less than c. Think back to what we did here to why this makes sense on these two examples, working with real numbers. Right? What this is telling us is that, well, a minus b could be positive, in which case it's got to be less than c, or a minus b could itself be negative, but in absolute value we'll make it positive, and then it's got to be less than c. So this part tells us that negative, if this is negative, it's got to be bigger than negative c, in order that when we take its absolute value and change the sign, that we get less than c. For the original statement involving absolute value to be true, it must be the case that the quantity a plus b is in between minus c and c. Okay, so just say a little bit more. If the quantity a plus b were less than negative c prior to taking the absolute value, then after taking the absolute value, we get something larger than c. So here's an example. Absolute value of x is less than 1 tells us that x has to be between negative 1 and 1 without the absolute values. All right, so let's try some values. Let's try 0. Absolute value of 0 less than 1? Sure. What about absolute value of negative 2? Ooh, absolute value of negative 2 is in absolute value, it becomes positive 2. That's not less than 1, right? So that's something, so note, values smaller than negative 1 will be larger than 1 in absolute value. Just like our example of negative 2. Negative 2 is smaller than minus 1, so it is larger than 1 in absolute value. It's 2 in absolute value. All right, let's solve this inequality. We know either this is positive and then less than 10 as written, Or this here is negative, but then it has to be bigger than negative 10. We'll solve these. So here's just the explanation. If 3x minus 4 is negative, in absolute value it would be positive and must be less than 10. We need the inequality to reflect the fact that prior to taking absolute value, the quantity 3x minus 4 must be greater than negative 10. All right. So let's solve each absolute value inequality. If we solve the first one, just divide through, move the 4 to the other side, divide through by 3, and we have x is less than 14 thirds. What about this one? 3x minus 4 is greater than minus 10. Let's move the 4 to the other side, divide through by 3. We have x must be greater than negative 2. So here's our statement. X must be between negative 2 and 14 thirds. And you can try some values. Suppose we have a more extreme value like negative 3. Negative 3 times positive 3 is negative 9. Minus 4 is minus 13. In absolute value, that's positive 13. That does not make this true, right? So we can't have values smaller than minus 2. And we cannot have values more extreme than 14 thirds. Okay. And then the last one, absolute value of 2 minus 3x is bigger than or equal to 12. Well, our solution says if this thing's positive, this must literally be bigger than 12 or equal to 12. So that's this one. Suppose this thing's negative, well, then it's got to be smaller, more extreme than negative 12. So 2x minus 3x, or 2 minus 3x cannot be between negative 12 and 12. So we need it more extreme. So 2 minus 3x is less than or equal to negative 12, or x is bigger than 14 thirds. And 2x minus 3x is bigger than 12, or x is less than negative 10 thirds. So the solution is either x is bigger than 14 thirds, or it is less than negative 10 thirds, right? Let me just try one value. So what this is doing is this is splicing off the range of values into the extreme. So it's allowing values more extreme than negative 10 thirds in the low direction, and values more extreme than positive 14 thirds in the positive direction. What we're missing is everything in between negative 10 thirds and positive 14 thirds, which includes 0, because one is negative, one's positive. So we're losing 0 amongst other things in the middle. So let's just try 0 and see if this works. 3 times 0, oh, that's 0. 2 minus 0 is 2, which is not bigger than 12, right? So just by testing one value, we see, so either x must be more extreme, more positive than this, or x must be more extreme, more negative than this. Cannot be in the middle, cannot be 0. What if we try something in the middle? It doesn't work, right? And you can go ahead and try some other values to see if you get this to work for larger ones, or try negative 1, and so on and so forth, and see exactly, get a feel for exactly how this is working. Okay. Very good. Let me know if you have questions.